Welcome to today's deep dive. When most of us picture an AI data center, you probably imagine like a single giant brain just humming away in a dark room.
Right, some freezing cold, glowing room.
Exactly. But to really grasp where the technology is heading based on Jensen Huang's recent All-In interview, you kind of have to throw that image out. It's actually more like a highly specialized industrial assembly line where literally every microsecond matters.
Yeah, because when you ask an AI to, say, book your flights and manage your calendar, you're kicking off this process that requires just absolute mechanical precision.
Right. So our mission today for you listening is to unpack how spending a staggering $50 billion on a specialized data center mathematically results in cheaper AI for you.
It sounds totally counterintuitive, I know.
It really does. But to understand it, I mean, to manage an assembly line this complex, you need a master conductor, right?
Right, which requires a complete rethink of architecture and, crucially, thermodynamics.
Hmm.
Nvidia calls their master operating system Dynamo. Yeah, and the original Dynamo was a Siemens machine that essentially turned water into electricity to power the last industrial revolution.
Oh, wow. So the name signals this is the engine for the next one.
Exactly. But what Dynamo actually does on that assembly line is run something called disaggregated inference.
Which sounds very technical.
It is. I mean, the inference processing pipeline is arguably the most complicated computing problem we face today. You can't just hand the whole job to one chip anymore.
It would just choke.
Completely. So Dynamo disaggregates or, fractures these massive workloads across a really heterogeneous mix of hardware. We're talking GPUs, CPUs, scale-up switches.
Wait, so instead of forcing a single GPU to do all the heavy lifting, the system is dynamically routing the exact right workload to the exact right chip, like sending welding to a GPU welding station while sending memory retrieval down a specialized CPU lane.
That is a great way to visualize it. The hardware itself has physically evolved to handle this fragmentation.
So if the hardware is changing to match the software, that actually explains Jensen's 25% mandate.
The Vera Rubin architecture allocation, yeah.
Right, because in the interview, he said for high-value inference, a full quarter of the data center space is allocated to a GROC, LPU, and GPU combo. But why dedicate 25% of your massive factory to that one specific mix?
Because we're moving away from simple chatbots toward agentic AI. An agent doesn't just read a prompt and spit out an answer.
Right, it has to do a lot more.
Yeah, it pauses, it retrieves memories from storage, tests digital tools, talks to other models.
And all that constant back and forth fetching of tiny contexts, that just completely bottlenecks standard memory systems. Right?
Oh, absolutely. Agentic systems just beat up on storage. It creates a massive traffic jam. You need that specialized GROC and GPU mix because it's designed to process language and memory fetches incredibly fast.
So it prevents the system from choking on its own data traffic.
Exactly.
But I'm really struggling with the economics here. Implementing all this hyper-specialized hardware sounds insanely expensive.
It definitely is.
Right, so if a competitor builds a factory for half the price, say $25 billion, instead of NVIDIA's $50 billion, how does NVIDIA avoid getting completely undercut on the price of a token?
Well, that assumes the upfront price of the factory dictates the final cost of the product. Let's look at the fixed costs. Out of that $50 billion, around $20 billion goes strictly to basic infrastructure.
Meaning like the land and the shell of the building.
Land, the shell, and crucially, the thermodynamics. The massive power and liquid cooling systems required to keep these dense clusters from just melting down.
So the concrete, the electricity, and the air conditioning cost the exact same no matter whose chips you buy.
Precisely. You pay that base infrastructure penalty regardless. So, yes, the premium for top-tier hardware might bump your total cost from $40 billion to $50 billion.
But it clears the memory bottlenecks we just talked about.
Right, which means it delivers 10 times the throughput.
Wait, really? So even if a competitor gave away their chips for literally free, it still wouldn't be cheap enough because the slower throughput creates a massive bottleneck.
Yeah, you would be losing money on the thermodynamics alone.
Yeah.
The hardware premium buys throughput, and mathematical throughput is what drives the cost per token into the ground.
Which means, for you listening, this relentless push for throughput efficiency is exactly why having powerful AI agents manage your everyday life will soon be incredibly cheap.
Yep, but it all hinges on managing the heat. Cooling these clusters is becoming the absolute ceiling of the AI factory on Earth.
Which leaves us with a wild thought to mull over. If a $50 billion factory on Earth can make AI tokens practically free today by maximizing throughput, what happens to global computing power when we eventually build these AI assembly lines in space?
Oh, wow.
Just imagine running an AI factory on infinite solar radiation with the freezing vacuum of space completely removing our terrestrial cooling limits. That is an assembly line with no speed limit.